again, everybody. Brian Forget, welcome back. And today we're going to be talking about spanning tree edge port, or Portfast? It kind of depends. And we're also going to talk about BPDU filter and BPDU guard, which are not the same thing. The short version is that if you're configuring one of your switch ports to connect down to some kind of end device, server, SAN, client, probably set it to port type edge port, maybe Portfast, different name, same thing, and probably BPDU guard. All right, let's get into it. This is a continuation of our spanning tree discussion from last time. If you're looking for more details on how to set one switch or another as root and why you might want to go check that one out, now or maybe after, whatever. And I'll try and put a card somewhere up there to make it easier on you to get to it. Today, we're going to be talking about how you might configure some port that is not connected to some other switch running spanning tree. And to do that, we already said that we are going to be talking about this idea of Portfast, or maybe edge port. Yeah. And then also this idea of BPDU guard, and just kind of cover it because there's some confusion there sometimes, BPDU filtering as well. All right, so time for Tiny Brian. And let's go nail down some terms first. Like we said, right, spanning trees are sort of a big topic here, but we'll pull up a drawing real quick, right? We're trying to configure the ports on those switches that are connected down to some end device. Your laptop, a printer, a server, a SAN, right? Maybe even an access point, depending on what you're doing. Any of these things, you would likely want to set them up for this Portfast or edge port, different names depending on the context, but basically the same thing. That's the goal. That's what we're doing here. So Portfast and edge port. Why the two names, right? Why one or the other? Basically, what it comes down to is that the original version of spanning tree, classic spanning tree, legacy spanning tree, 802.1d spanning tree, called this thing that you'd want to configure on those ports going to your users, they called it Portfast. And forever ago, but after the original spanning tree, there's this thing called rapid spanning tree, and all the timers got faster and is just significantly better. Everything I've described in the last video was actually rapid spanning tree. And for a lot of circumstances, I would argue that today you probably want to use rapid spanning tree. There are other types as well that we'll get into in other videos, but for the moment, and once rapid spanning tree came out, this technology that setting that you want to have on those ports, they changed the name to edge port. Basically the same thing. Some switch operating systems will just call it one or the other because maybe that command line came out at a time when, the Portfast was the only thing. And so, yeah, it's just the word for it. Maybe newer ones call it edge port. I've even seen it where some operating systems call it Portfast, but only if you're using old spanning tree and edge port, or maybe port type edge for rapid spanning tree. So be a little careful there, but that's the context. Okay, so there's these two different names for this technology, Portfast, but what does it do? Why are you using it? Well, it solves two problems for you. And that is to bring the port up fast and to not cause a topology change when that port goes up or down. Originally, the first one of those solutions was the bigger deal, probably, the one that you'd notice right away. On the original spanning tree that was slower, if you did not have your ports going out to those users configured as Portfast, the symptom you would see is that someone would power on their computer, it would boot the whole way up, they'd get logged in or whatever, and they wouldn't have an IP address. Because the switch would wait so long before it would allow traffic to forward on there that operating system would have given up on getting a DHCP address before spanning tree would forward. And so Portfast, that name made a lot of sense. Once rapid spanning tree came out though, instead of waiting a minute and a half potentially before your port would start forwarding. Now the longest you would wait is about 15 seconds with rapid spanning tree. And your computer you're not going to have problem pulling a DHCP address before spanning tree starts forwarding. And that, as I understand it, is why the name changed in rapid spanning tree. It still solves that problem of bringing the port up instantly without going through all that learning and everything phases. It just goes straight to forwarding. But you're less concerned about the speed. This not causing a topology change when the port goes up or down, though, that is still a really big deal. And here's why. Every time, in fact, I'll just minimize this. There we go. Back to our diagram from last time here. Every time you plug in a cable to some switch on some port that's running spanning tree, that switch is going to check to see, is there another switch over there? Is it getting some little BPDU message, Bridge Protocol Data Unit, spanning tree control traffic? Is it getting some message like that coming down the wire and hitting it? And if so, it's going to need to go figure out, is this a new, better path to route? Is this an alternate path to route? And as part of that, if that link comes up and the port is not set to this Portfast or edge port, the switch will trigger a topology change. Topology is like the lay of the land. A topographical map is one that shows like elevation and everything. Topology here is the lay of the land as far as the network is concerned. And so a topology change means a cable got plugged in and suddenly there's a new network map. Or a cable got unplugged and there might be a new network map. When your switch registers that port going up or down, as long as it's not set to, edge port Portfast, it'll do this. And it gets that topology change, it will dump its MAC address table, forget who root is, send out a spanning tree topology change notification, TCN message out all of its other ports running spanning tree to let everybody else know that there has been a topology change and that they should dump their MAC address table. They should forget who is root. And now we all run a new root election. And that's a good thing, as long as I've just unplugged some cable between these two switches or plugged in some new cable between these two switches. That's what allows spanning tree to essentially heal to find the new best path. I love it. But while it's doing that, no user traffic is flowing. And so you do not want that happening unless there's genuinely been a topology change. But if it's just me over here and I'm powering on my laptop for the day, or plugging in my laptop to my docking station, and so the NIC is coming up that's plugged into the switch in the wiring closet or whatever, I don't want a topology change to happen. There's not some new path through the network, it's just my laptop. And so that is the big deal. That is why you would want to have this Portfast or edge port, again, different switches will call it different things, on all of your end devices. Okay, so what does it look like if you don't have that configured? What symptoms would you be seeing that would say, man, I gotta go turn this thing on? Classically, the thing that I ran into in a campus environment, which is to say user space, user environment, would be that for the first about a half hour in the morning and right after lunch, the network sucks. Everyone complains, everything is so slow in the morning. There's no reason for me to show up on time, right? And the reason is because every time somebody plugs in their laptop or reboots it in the morning or whatever, powers on their desktop, whatever, the switch they're attached to dumps its MAC table and tells everybody else in that layer 2 network that they should as well. And then they run an election and figure out who's root and everything, and nothing's changed. It'll just be the same switches. And then it'll start passing user traffic again, and then the person next to me reboots theirs. And then over there, someone else does too. And so, yeah, in a campus environment, the thing you would need to do then is set all of our user ports to that edge port or Portfast. And now, when we power on in the morning, no topology change. Yeah, we're going to forward right away, but we're not messing it up for everybody else with this whole topology change business. That's in the campus environment. In a data center environment, what I've seen is that maintenance windows are worse than you think they should be. Because you almost never reboot those servers. Yeah, you move your VMs around, but like that stuff, you set it up and it's just running forever. And then you go to have some maintenance window because you need to update ESXi. And so you moved all your VMs and everything off of there. And then you go to run that update and reboot the server. And suddenly you get like maybe a corrupted database. Or, some VM that should have been working perfectly fine, some access to storage that should have been working perfectly fine is lost. Because you effectively, in powering off your server and powering it back on, have unplugged and plugged it back into the network. And everyone else on your switch, well, we dump their MAC address table on the switch, and we don't allow user traffic while we're figuring out who root is again. And so that's why I'm saying maintenance windows go worse than you expect. Weird things that don't seem to make sense because you just rebooted this computer, or replaced the controller, or whatever, brought this SAN down, something like that. And other devices were affected as well. Same thing. Port type edge, edge port, or Portfast. Okay, so how do you configure it? Let's see. Okay, this is not Cisco. This is just on one of these OS X systems here, but it's going to be pretty darn similar. What I'm going to do is I've got things set up so that the switch number 1 is root. And so this switch number 2 is forwarding on its port number 117. And switch number 3 is forwarding on its port 118, because those are its root ports, or their root ports. And then one of the two of them is blocking on this ETH 119, connecting the two of them up. If I remember correctly, it's switch number 2 here. Okay, it looks like I'm in the command line of switch number 3. What I'm going to do is I'm going to go to this port 111, and I'm going to set it to that edge port. So config. And if it was Cisco, I need to do config T or conf T. I'm going to head over to that port, interface ETH 1/1/1, spanning tree. And for this one, port type edge. Press enter. And now it's an edge port. And now if that port goes down, there won't be a topology change. If it comes up, then it will not cause a topology change either. Yeah, so I can do a show conf on that one. This operating system show configuration gives you the running configuration of the interface you're at. And I can see it's in switchport access VLAN 1, spanning tree port type edge, and no shutdown. If I do a shut and no shut and do show span active, well, it's already, it knows who's root. It wasn't going through a process or anything to refigure out who root was, because there weren't any topology changes. That easy. We're good. So yeah, in this operating system, again, it's spanning tree port type edge. I've definitely seen somewhere it's spanning tree edge port, or again, spanning tree Portfast. Likely it's all the same thing. Okay, moving on. Going quicker today. We are going to be talking about BPDU guard and BPDU filter. And the short version is you probably do not want to use BPDU filter. You probably want to use BPDU guard with EdgePort or Portfast. Probably want to use, I'm just going to say EdgePort from here on. You probably want to use EdgePort and BPDU guard together. And here's why. BPDU guard, let's write it down, says if any spanning tree message shows up on this port, turn the port off. Different operating systems will do it a little differently. It might show up as link inconsistent. It might show up as error disabled. Subtle differences, but either way, if you enable BPDU guard on some port, then if a BPDU, a spanning tree message, shows up on that port, it gets turned off. Okay, versus BPDU filter. The one you probably don't want to use. This says if any spanning tree messages show up, ignore them. Throw them away and don't tell me about it. And like I said, you probably don't want to use that. There's some circumstances where it makes sense, but probably not. And so here's what it comes down to. Our spanning tree edge port. We said you're going to configure that probably on all of your ports going down to user, server, SAN, whatever. But let's imagine your desk at your office. So you're sitting in your office and you're having a great day and everything, and you decided, I just don't have enough ports at my desk. I've got the, the 2 ports in the floor jack maybe, but I really want more. Or maybe only one of them works, and I really want more so I can hook up more devices at my desk. And you have picked up some cool thing on eBay and plug it in. And it's a switch, right? And so you plug in, port 1 to the floor, and now you've got all these other ports at your desk to plug in whatever you want. And they can talk locally, no problem. And when you do need to talk to the wider network, all right, well, it forwards up through that link down to the desk. Huzzah, hooray, and everything's great. Except, I do not want your switch taking part in spanning tree. I don't want you having your own network there. Because, maybe you take both of those jacks, because they are working, and you plug them into port 1 and 2, because you want twice as much bandwidth. That's not how that works. Got to be configured on both sides. And you just caused a loop. Or we did that yesterday. The 2 wires between, or last time, the 2 wires between the 2 switches is a loop. That's no good. If I've got you set to Portfast edge port, well, I'm not checking for that. I'm just bringing you up right away. And if I have you also set to BPDU guard, then when those spanning tree messages hit the switch, we are going to disable your ports. And now you have to put in a trouble ticket to say, my ports don't work. And we can say, oh, well, I see why. Tell me about that switch you plugged in there. Don't do that. I'll turn it back on for you, no problem, but just don't do that again. Okay. BPDU guard fixes the problem by killing your port when you try plugging in some spanning tree aware device to it. Because my edge port is going to keep it from preventing loops. If I'm doing edge port and BPDU guard, well, that's going to keep it from having problems when those loops show up. When it would have showed up, I should say. Okay, so yeah, very, very likely for all those users, you're going to say something like spanning tree port type edge, and then on that same port, spanning tree BPDU, there we go, guard. And this one, enable, my bad. Okay. And now, yep, there we go, spanning tree BPDU and guard enable, spanning tree port type edge. Awesome, we're good. The filter that you probably don't want to use. Here's what would happen if you did. Now, switch gets plugged in, and you've got maybe your both ports 1 and 2 connected up, and I've got edge port set up on there, so you just forward right away. If I also have BPDU filter enabled on my ports, then you send me your spanning tree messages, my switch discards them and doesn't log it or anything. And now there's a loop. And you're not seeing your own spanning tree messages coming around, so you can't protect us. And I'm not letting you take part in the spanning tree at all. And so, yeah, now there's just this loop, and that's no good. So that's what BPDU filter would do. And that's why you would not put it on those end ports, those edge ports. Here's where you might use BPDU filter. If you've got some real long leak, in fact, I'm not going to type it here. Here's when I've run into it being helpful. If I've got a switch here, and we've also got another switch like 20 miles away, and we actually have fiber running between here and there, or microwave links running between here and there, so that we have a layer 2 link between this switch and the next one over, but it's really, really far. The default timings for those hello messages, for the spanning tree messages, can actually come into play where, like, yeah, there's a layer 2 link between here and there, but there's so much latency between here and there as well, potentially, depending on the media that's being used, that it might be that spanning tree can't communicate effectively. And so I don't want to run spanning tree on that link because it can't communicate effectively. What I might want to do specifically is put on BPDU filter to ignore any spanning tree messages that come from over there as well. Now, you might worry, oh no, but like now we got the whole problem with a loop, right? I'm probably not going to accidentally connect a second cable between these two sites if it requires getting a license from, like, you know, the folks between here and there, or renegotiating with the railroad that I'm running these cables along, or setting up new microwave links, right? It's very low, relatively low, I should say, chance of accidentally connecting a second layer 2 connection between here and there. And so in that case, probably BPDU filter. The other would be if you're connecting to network infrastructure that you don't own. Maybe you're providing a link to someone else and you're like a managed service provider or something like that, and you don't want to accidentally take part in their spanning tree. So BPDU filter so it doesn't get flooded out past them. Or vice versa. Someone's providing a link to you. Now, in those cases, it's more likely a routing situation, so you're less likely to worry about spanning tree, but that's the other time you might want to filter, when it's saying, look, I need to have user data go between here and there, but this is a protocol I don't want to take part in from some infrastructure I can't control. Okay, so recap. Spanning tree, edge port, and BPDU guard is very likely what you're going to configure on all of those ports that are going down to your clients in the campus environment or to your servers, SANs in the data center environment. And BPDU filter, you're less likely to use, but if you're gonna, it's because you don't want whatever device is the other end of that cable to provide you any spanning tree messages. You don't want to take part in whatever's going on there, but also there's very low likelihood of having a loop, right? That really, really long connection between these sites, or connecting to, like, you know, managed service provider or something like that, where there's not a second layer 2 link. Everybody, thank you so much for being here. This continues to be a blast. Really appreciate it if y'all let me know in the comments, what can I do for you, right? Do you have questions about this? Drop it on in there. I'm checking these things out. Same for the other videos. If you've got ideas for something you want me to talk about next or down the way, I love it. Drop it in there. Let me know what I can do for you, like I said. And like always, right? I'd really appreciate it if you like, and if you like what's going on here, subscribe. Thanks so much. We'll see you next time.
Oh man, I thought he'd never leave. Anyway, kids, so why'd the playground cross the road? To get to the other slide.